This is problem 4.3.27 from the book. The function that we're given is x to the fourth minus 8x squared plus 16. And in part A, we need to find where this is increasing and decreasing. So let's consider the derivative. So our derivative is 4x cubed minus 16x, which we can factor this into 4x times x squared minus 4. We can further factor this. Plus 2, x minus 2. Alright, so now we need to find the critical points. So critical points are when the derivative is undefined, which in this case it is never undefined, or when it's equal to 0. And in this case you can see it's equal to 0 at x equals 0, x equals negative 2, and x equals 2, just by setting these three parts equal to 0. So now we know our critical points. Let's see what they tell us about the function. Negative 2, 0, and 2. So let's consider a point in this area, negative 3. F prime of negative 3 is 4 times negative 3 times negative 3 plus 2, negative 3 minus 2. So that's going to be positive times a negative times a negative times a negative. So that's going to give us a negative value. It doesn't matter what that value is, we only care about its sign. So now let's consider something in this area. Let's try negative 1. So f prime of negative 1 is equal to 4 times negative 1, negative 1 plus 2, negative 1 minus 2. So that's equal to a positive times a negative times a positive times a negative. So that's going to be a positive value. Now let's consider something in this range. Let's try 1. F prime of 1 is going to be 4 times 1, 1 plus 2, 1 minus 2. So that's positive times positive times positive times a negative. So this is going to be a negative value. And finally, let's try something in our last range. Something greater than 2, so let's try 3. F prime of 3 is equal to 4 times 3, 3 plus 2, and 3 minus 2. And all of these numbers are positive, so this is going to give us a positive value. So what does this tell us about our function, about the graph of our function? We can see that from negative infinity to negative 2, and from 0 to 2, our function is decreasing. And from negative 2 to 0 and 2 to infinity, our function is increasing. So this is our answer to part A. Now let's see if we can use this information to find out the absolute and local maximums. Well, you can see from here that we're going to have, this is just a basic shape, we're going to be decreasing, and then we're going to be increasing, and increasing, increasing, increasing. That's a really bad graph. Let's redraw that. Let's start over. Decreasing until this point, then increasing, then decreasing, then increasing. So you can see that we're going to have local min at x equals negative 2 and 2, and local max at x equals 0. Now let's consider our absolute minimum maximum. Well, clearly you can see that we're not going to have an absolute maximum because this is just going to go on forever, and this is just going to go on forever here. So there's going to be no absolute maximum. But one of these points is going to be our absolute minimum, maybe both. Let's see. So we need to plug them into the original function to get their value. So we have f of -2 and f of 2. That's -2 to the 4th minus 8, -2 squared plus 16. If you multiply this all out and add, you're going to get 0. And then likewise over here, you're going to get 0. So we have an absolute minimum. We have two of them. We have one at x equals 2 and one at x equals -2.